So bearing is always measured from the north. And not only that, but its bearing is always measured from the north going east, which means going to the right, going clockwise. So this is north. If I want to sketch a bearing of 28 degrees, I always start at the north. So I start here. 28 degrees is going to be this way. And remember, we're always going towards the east. This is 28 degrees. So a bearing of 28 degrees would look like this. Okay, we start from the north and we always go clockwise. So we always go toward the east. And that is going to be a bearing of 28 degrees. Let's say we want to sketch a bearing of 120. So again, anytime you see the word bearing, you're always going to be starting from the north, and we're going to go clockwise. So this is 90, and 90 plus 30 is 120. So this is 30, and this will be a bearing of 120 degrees. Now for our lesson today, it's going to be super important for us to sketch that reference angle. So in this case, it's 30 degrees. Make sure you always sketch that. Any questions on the first two? Let's say we want to have a bearing of north 38 degrees west. So what does that mean? So we start from the north. So the first direction tells you which way to start from. The second direction will say go 38 degrees toward the west. So we have north, south, east, and west. So from here, if I want to go 38 degrees west, then I'm going to go this way. So this represents, so the way you would read this is 38 degrees west of north. So we're going north, and then as you're traveling north, you're going to turn 38 degrees west of north. So you would read this as 38 degrees west of north. The next one says you got 220 degrees east of north. So the way you would read this is 220 degrees east of north. So we're going north. And then as you're traveling north, we're going to turn 220 degrees going toward the east. So this is north, this is east. 220, that's going to be 90. Plus 90 is 180. And then 180 plus 40 is 220. So this is going to be 220 degrees east of north. Any questions on sketching the bearings? Just a quick reminder, the ones we're going to be using in this section are going to be alternate interior angles. So anytime you got two parallel lines and they're cut by a transversal, these angles are called alternate interior angles, and they're going to be equal. The lines don't have to be horizontal. Let's say we have two vertical lines that are parallel. They go like this. So this line and this line are parallel, and they're cut by a transversal. Same thing happens. The alternate interior angles are both going to be equal. All right, any questions on the basic stuff before we get to the examples? Okay, so first example, it says that from A to B, a private plane flies 2.4 hours at a speed of 110 miles per hour on a bearing of 29 degrees. Then it turns. So maybe it's a cargo plane that drops off some cargo, and then it turns to another point C to drop off more cargo. So at this point, at point B, it turns and continues 2.54 hours at the same speed, but the bearing is now 119 degrees to point C. We want to round our answer to each answer to 3 decimal places. So question A says, at this time, how far is the plane from its starting point. Now, the drawing is going to be extremely, extremely crucial. So we have to make sure we draw nice and clearly and label everything. Okay, so I'm going to start by saying this is point A. This is where the plane starts. And it's at a bearing of 29 degrees. So remember, bearing is if you're going north and you turn 29 degrees clockwise toward the east, this will be your bearing. So this plane is going this way at a bearing of 29 degrees. So it's gonna get to a certain point. Okay, I'm gonna call this point B. And then at point B, it's gonna turn again, but now it's gonna have a bearing of 119 degrees. So every time you change your bearing, you have to draw a new coordinate plane. You need the coordinate plane to figure out what your bearing looks like. So at point B, I'm going to draw another coordinate plane. The bigger the better. I'm kind of out of space here, but the bigger the better. So now let's draw a bearing of 119, and I'm gonna change colors here. So to get a bearing of 119, bearing is always going to be starting from the north and going 119 degrees clockwise, which means toward the east. So this is 90. And to figure out the rest, if I take 119 minus 90, that'll give me 29 degrees. So it's going to turn another 29 degrees. And that's going to be a bearing of 119. Okay, any questions on sketching this new bearing here? So now our plane is going to turn this way, and it's going to go toward point C, which is here. And it stops there. Okay, before we continue, any questions so far on this? I'm not getting that 29 the way I want. I'm sorry. I'm gonna try one more time. Real quick. Okay, it's a little better, I think. So now our plane is here. So any questions on the sketch before we continue? Now our first question is, at this time, how far is the plane from its starting point? So what we want to know is, we want to know this distance here. And because this is a triangle, I'm just going to label the sides. Opposite of angle A is always side A. This is point B. And so opposite of angle B is always going to be side B. So this is angle B here. And opposite of angle B is always going to be side B. And then opposite of angle C is always going to be side C. We want to know what is the length of B. So that's your variable. You want to know what is this length here. So let's figure out what do we know, because it doesn't look like we have a lot of information. So what do we know? We know that the plane flies for 2.4 hours at a rate of 110 miles per hour from A to B. So I can find the distance, right? So this distance is given by rate times time. So from A to B, the rate is 110 miles per hour. The time is 2.4 hours. And if I plug this into my calculator, I'm going to get my distance is 264. So from A to B, the distance is 264. Now from B to C, coincidentally, it's the same distance because it's still same speed and the same amount of hours. So that's also going to be 264. For your homework, these distances will not be the same or may not be the same. So be careful with that. If you're going to follow the example, don't just copy down the same distance. If the time was different, then your distance would be different as well. So now we can't use Pythagorean theorem because we're not sure if this is a right triangle. So because we don't have a right triangle, we can't use the Pythagorean theorem. Okay, but what we know is we know that we have these two sides whose values we know. And we also learned in the law of cosines that if you're given two sides and the included angle, then we can use a law of cosines to find out what side B is. And this angle is made up of two smaller angles. I'm going to call the first one x1, and I'm going to call the second one x2. Okay, let me stop here and take any questions that I can clarify up to here. All right, so let's find x1 and x2. So x2 is going to be easier to find, so I'm going to do that first. 90 and x2, they add up, or 29 and x2, they add up to 90 degrees because they make up this this bottom half, the quadrant 4. So 29 plus x2, that's going to add up to 90 degrees. So if I subtract 29 from each side, then x2 is going to be 61 degrees. So now we just got to find x1, and then we'll have our angle. So here's what we know about x1. This line and this line are parallel. So I'm going to draw it on the side. So we have this line and this line. They're both parallel to each other because we drew two coordinate planes. And then we have this transversal that's going to cut these two angles. And we know that this angle here is 29 degrees. Now, according to the alternate interior angles theorem, this angle will also be 29 degrees. So if this is 29, then x1 also has to be 29 degrees because they're alternate interior angles cut by a transversal. We have two parallel lines. So x1 will also be 29 degrees because of alternate interior angles. Any questions on that part? So now if I add x1 plus x2, this will be 29 degrees plus 61 degrees. And that'll be 90 degrees. So now I know that this angle, this whole thing is going to be a 90-degree angle. And now I have my two sides and my included angle. So I can use the law of cosines. The law of cosines says anytime you have two sides in the included angle, you can find the measure of the missing side, even if it's not a right triangle. So because we have the variable b, we're going to use the formula b squared is equal to a squared plus c squared minus 2ac times the cosine of b. If I plug this in, my a value is 264. My c value is also 264 minus 2 times a times c times the cosine of b, which we now know is 90 degrees. Okay, I'm going to pause and take any questions up to this point. So I see a question in the chat. Yeah, Emma, go ahead. What's your question? So at this point, we can use the Pythagorean theorem because it happens to be 90 degrees. But let's say in your homework, it's not 90. Then I wanted to show you a method that's going to work with every triangle. So even though in this case, yes, we can use the Pythagorean theorem. you can just do a squared plus b squared equals c squared. But what if it was like 88 degrees? Then you couldn't. So that's why I'm doing it this way, to make a general case. Right? Good question. So so now we have b squared. So 264 squared plus 264 squared minus 2 times 2. So if you put this all in a calculator, you're going to get 139,392. And then if you square root that, the length of B is going to be 373.352 miles. So that's how the plane is from the original point. Now so any questions on part A? Part B says, on what bearing from due north is a plane from its original location? So first, let's figure out what this question is asking. So this is point A, the plane is now at point C. So let's say that point B never existed and the plane just flew straight from point A to point C. We want to know what bearing do we have from the north? So we want to know this entire angle. Now we know the first part of it is 29 degrees. We don't know what this is. I'm going to call this x3 because I already used x1 and x2. So now if we find out what this angle A is, then the bearing from A to C, measuring from north, is going to be 29 plus x3. So now we just got to find out what's x3 equal to. So now here's what else we know. So we can do this in two different ways. We have two sides and the included angle. So we can use the law of cosines if you wanted to and solve for the angle. Or because we now have an angle and its opposite side, both of who are known, we can also use the law of sines. So let me repeat that. One way I can do this is we have two sides and the angle that's included is unknown. So and we know what the third side is, so I can use the law of cosines to do it that way, but that's a little bit harder. I think the easier way to do it is to say that we have 90 over 373.352. That's a law of sines, and that's going to equal to angle x3 over 264. Anytime you have a known angle and its opposite side, we can use the law of sines. So the law of sines says that if you have sine of 90 degrees over 373.352, that is the known ratio, that equals to, we want to know what is x3. So that's actually angle A. So I'm just going to call it angle A. That equals the sine of angle A divided over its side, which is 264. So for all these problems from this section, you're always going to start with the law of cosines and then use the law of sines. It's going to be the order if you want to make it simple. Any questions on the setup?
Professor, when you say that, do you mean so try law of cosines, but if that doesn't work, move to law of sines? Or
no? So like in part A, we use the law of cosines in order to find out what this missing side was. And then so in part A, you would use that. And then once you have the missing side, then you can use the law of sines to find out the missing angle.
Got it. Thank you.
Yeah, thank you. So so at this point, we're going to cross multiply. And by now, you may have figured out you don't actually have to cross multiply. I do it to keep it consistent, but all we're really doing is we're moving the 264 over to the other side. So we're just multiplying both sides by 264. But to keep it consistent, I'll just cross multiply. So on the left side, I get 264 times sine of 90. On the right side, I get 373.352 times sine of A. And I want to solve for A, so I'm going to divide both sides by 373.352. So those cross out. And then I get the following. On the right side, I get sine of A. Now, in your calculator, if you type in 264 times sine 90 divided by 373.352, it's going to give you a decimal. It's going to give you like 0.707, 107, 502. And then if you take the inverse sine of each side, to remember to undo any sign, we got to take the inverse sine of both sides. So if I take the inverse sine of the left and the inverse sine of the right, then I'm going to get angle A is approximately 45 degrees if I round it.
Excuse me, Professor.
Yeah.
After the arrow from the first time, you wrote 265 sine 90, right? Over 373.352.
Yeah, so it's 264 times sine 90 equals
Okay.
to, and then you just divide both sides by the 373.3.
Okay, no worries. Thank you.
So now we know that so angle A or x3 here, this is going to be equal to 45 degrees. So the bearing, remember, bearing from A to C is measured from A from the north going all the way until this vector. So that bearing is 29 plus 45. So if you take 29 degrees plus 45 degrees, this will give you 74 degrees, which is going to be the bearing for letter B. Any questions on either of these? I think that if you follow along with your notes when you're doing homework, you should be fine, hopefully. If not, that's what I'm here for. You can ask me questions. Okay, example 2. It says a person leaves home and walks 6 miles west, then walks 2 miles southwest. So let's first label these as north, south, east, and west. So what we have is a person is from, so this is home, and a person is walking 6 miles west. So west is going to be this direction. So this person is going to walk 6 miles going towards the west. And then from here, that person turns southwest. So southwest is going to be, while going west, you're turning south. So southwest is going to be this direction. So that person turns southwest and walks for another 2 miles. So that person ends up right there. Now the question is, the first one is, how far from home is this person? So we want to know what is this distance here. Now, if I label this as A, B, and C, this is A, this is B, this is C. I'm looking for the length of side B. That's what I'm looking for. Now I have two sides. If I just knew what this included angle was, then we'd be in business. We would easily be able to find the length of B using the law of cosines. Now here's kind of an assumption we have to make here. This person went southwest, but we don't know how many degrees this person turned. So we're going to assume that this person made an exact 45-degree turn going towards the southwest. So this is going to be 90 degrees. Here it's 90. So we're going to assume that this is 45. So if you add 90 plus 45, then this angle is going to be 135 degrees. So for this problem, when you do it on the homework, just assume that that angle, that included angle is 135. She could have turned 40 degrees. She could have turned 50 degrees going towards the southwest. Since we don't know, we're going to make an assumption that she turned in a perfect 45 degrees when she turned that way. Any questions on the setup?
So what you're stating is southwest equals a 45-degree turn.
Exactly. So yeah, so we're going to assume that in this case, the southwest turn is going to be 45 degrees, which makes this angle 90 plus 45 or 135. Our formula, once again, is going to be b squared equals to a squared plus c squared minus 2ac times the cosine of angle B. So let's plug all this in. In this case, a is 2 because it's opposite of angle A, so that'll be 2 squared. Opposite of angle C is 6, so C is going to be 6 squared minus 2 times 6 times cosine of 135. If you plug this in, we're going to get b squared is equal to 56.97056.275. Square root that, and you're going to get 7.548 is the distance from this person to her house. So if she were to walk straight home, she would have to walk 7.548 miles. Okay, let me pause for a little bit and take any questions.
Professor,
Yeah.
for an example like this, we will be given the degrees, right? Or
So we're going to assume that she turned an exact 45 degrees. That's our assumption. So 90 plus 45 would make 135.
oh, okay. 90 plus 4. Okay, thank you.
Any other questions? Okay, now the next part says, if this person were to walk directly home, how many degrees north of east does she have to walk? All right, so first, let's just figure out what they're asking. If they're asking, this is where the person is, and if this person wants to walk home, how many degrees does she have to turn? But we're going to say the degrees in terms of north of east. So what does that even mean, north of east? I'm going to draw a coordinate plane. Okay, so this is east, this is north, this is west, and this is south. North of east means if this person is facing east, how many degrees does she have to turn north in order to go home? So we're looking for this. This is going to be our x. I'm going to repeat that. If this person's going east, how many degrees does she have to turn north in order to get back home? So we want to know what is x in terms of north of east. East going north. You're facing east and you're turning north. So how do we find x? Well, luckily, this line and this line are parallel. And then we have this blue transversal that cuts them. So if this is x, this angle will also be equal to x. And now we have a known ratio. Our known ratio is that we have an angle of 135 and its corresponding side is 7.548. So we have sine of 135 degrees over 7.548. And since we want angle x, we look at its opposite side, which is 2 miles. So then that's going to be sine of x over 2. Okay, let me stop and take questions on the setup.
Professor, where do you get the 2 from?
The side that's opposite of angle A is the side which is going to be 2 miles.
Okay.
The southwest.
Okay, thank you.
Thank you. Okay, any other questions? All right, so now let's figure out what we're doing here. We're cross multiplying. You don't actually have to cross multiply. Remember, all we're doing is by now, I hope you realize that all you really have to do is bring the 2 to that other side by multiplying it. So we're going to say that sine of x is equal to 2 times sine of 135 degrees divided by 7.548. And then if you put that into a calculator, you multiply 2 times sine 135, divide that by 7.458. We're going to get 0.187362687. And then if we take the inverse sine of both sides, we take the inverse sine of the left, we take the inverse sine of the right, then we get the x by itself. And on this side, you put this into a calculator and we're going to get 10.799 degrees. So this person is 7.548 miles away from home. And if this person wants to go home and this person's facing east, that person has to turn 10.799 degrees north of east in order to go back home. All right, any questions? I'll go ahead, Emma. What's your question?
Professor, does it matter what mode the calculator is on? Because when I was inputting the equation for the law of cosines,
Yeah.
when I put it in, it didn't give me an exact answer. It gave me negative 12 square root of 2 plus 40 rather than like the exact answer.
It shouldn't be negative. So when you put all this in, was your 135 in? So is your calculator in degree mode?
Yes.
Okay. So if it's in degree mode, I wonder if you type something in incorrectly, because if you put in 2 squared plus 6 squared minus 2 times 6 times cos 135, you should be getting 56.97056.275. You shouldn't be getting a negative answer. But I think most calculators have, and I can't see your calculator unfortunately, but there's a little feature on some calculators. It's like this arrow thing that converts from exact form to decimal form. So see if you can like see if you have this arrow thing. If not, you can just use desmos.com to do this, and that'll definitely give you the correct answer. Okay, any other questions on this? Okay, last example. We have one more, but we're going to skip that fourth one. So this is example 3 is going to be our last example. So an airplane is heading north at a speed of 600 kilometers per hour, but there's a wind blowing from the northwest at 70 kilometers per hour. This is such bad grammar. I copied it from my open math. It's terrible grammar. It should say how many degrees of course will the plane fly? Okay, so let's first sketch what's going on. This plane is going north at a speed of 600 miles per hour. We're going to just deal with 1 hour at a time. So we're just, because everything's relative, we're just going to put everything in terms of 1 hour. And the magnitude of this plane, so I'm going to say P for plane, the magnitude of the plane is 600 or kilometers per hour. So the magnitude is going to be 600. If you think about it realistically, when you're flying, especially at a high speed, and you got to in that high up, you're going to have wind at a high speed. If you just keep going straight, you're going to get blown off course because there's a wind. So if you're like, okay, I just need to go straight up north, that's never going to happen. So pilots have to take into account the wind factor, and they have to adjust their bearings so that they're flying in the direction they actually want to fly. So it says there's a wind blowing from the northwest at 70 kilometers per hour. So where's northwest? So this is north, this is south, this is east, and this is west. So the wind is blowing from the northwest. So the wind's blowing this way. So the wind's it's gonna hit the plane right there. Boom. There's a plane, it's gonna hit the plane. When it does, it's gonna create the second vector. These two vectors are gonna collide. It's the second vector here. And the speed of the wind, which I'll call W, so the magnitude of the wind, is 70 kilometers per hour. So now the plane is going to be off course a little bit, which the pilots have to account for. So our question is, for one, how many degrees off course will the plane fly? And what's the plane's relative ground speed? So anytime you have two vectors that collide, the resultant vector starts from the beginning of the first vector and it goes to the end of the second vector. So this is our resultant vector. And the plane is going to be off course by theta degrees because the wind's going to hit the plane. So it's going to veer it going this way. Now, because the wind is coming from the northwest, once again, we're going to make an assumption that it's 45 degrees. It may not be exactly 45, but in this case, we're going to assume it's 45. Any questions on the sketch? Okay, so now we want to figure out what is theta. So to find theta, we know that the opposite side is 70, but we don't have a known ratio. So to get a known ratio, we have to first figure out what is this resultant vector. I'll call it vector S. What is the magnitude of vector S? So we have two sides and the included angle, which means we can once again use the law of cosines as always in this section. So we're going to say that S squared is equal to 600 squared plus 70 squared minus 2 times 600 times 70 times cosine of 45 degrees. And again, that 45 degrees, we just assumed it's coming from the northwest, so it'll be 45 degrees. It'll be a 45-degree angle. Now, if you put this into a calculator, just go left to right, put it in exactly the way you see it. Make sure you guys use parentheses and all that kind of good stuff. This is going to be 305, 503.0304. And then if you square root that, then S is going to be 552.723. So the magnitude of this resultant vector is going to be 552.723. And since these are all in kilometers, this will also be in kilometers. Any questions so far? So now we can use a law of sines. We can say, in order to find angle theta, we can say that sine of 45 degrees over 552.723 equals to sine of theta over 70, because 70 is the side across from theta. And then at this point, you don't have to cross multiply it because you want to get the sine of theta by itself. So we can just move the 70 to the other side by multiplying it. So we're going to have 70 times sine of 45 degrees divided by 552.723 equals to sine of theta. If you put that into a calculator, we're going to get this decimal is going to be 0.089. 552044 equals to sine theta. And then we're going to take the inverse of each side. We're going to take the inverse of the right and take the inverse of the left. And so if we do that, then theta is going to be 5.138 degrees. So this wind is going to blow the plane off course by 5.138 degrees. So if the pilots don't account for this, the pilots think we're going straight, the wind's going to make them go this way. They're going to be completely off direction. So they got to account for that. They got to adjust. That way they can keep going north.